we're going to take a look at our first lesson as we start Math 8, and that is to work on exponential notation. This is going to be a review. It is foundational for the topic of properties of integer exponents, and you should basically have an idea as to what an exponent is anyways. So many of these concepts should sound familiar, but as you'll see when we get into further concepts or further lessons, that we're going to be really expanding on what it means to be an exponent, a power, and a base. Alright, you should have your math journal and your lesson worksheet available. I'll be telling you what we will be working on or writing in, and I'll explain a little bit about how you should be writing in your journal. First off, let's go ahead and set some background. So when we add 5 copies of 3, we devised an abbreviation, a new notation for this purpose, and we called that multiplication. So if we add 3 numerous times, in this case 5 times, then instead of writing this whole long sentence of 3's, we abbreviate it as 5 times 3. Well, if we do the same thing with multiplication, let's say we take 3 and we multiply it by itself 5 times, how are we going to abbreviate this? Instead of a huge sentence again, is there a way we can come up with to simplify this? And if you remember from your previous experience in 6th grade and 5th grade math, the square of a number, you should have some dealings with that. If we have 3 times 3, we denote it by 3, and then 2 raised, it's called a superscript, but it's 3 and then a 2 that kind of hangs almost above the 3, almost like the 3 is flying a kite. From the expanded form of a whole number, you would have also learned that 10 to the 3rd power stands for 10 times 10 times 10. And as you talked about whole numbers and breaking them into their parts, you would have worked a lot with the powers of 10, and this is the abbreviation. When you have 10 times 10 times 10, we use 10 to the 3rd power. So this should be familiar to you. So therefore, employing this same idea, we would abbreviate 3 multiplied by itself 5 times as 3 to the 5th power. So it's 3 multiplying itself over and over again, and in this case it's 5 times, so it'd be 3 times 3 times 3 times 3 times 3 is 3 to the 5th power. Also, for any number, let's say we want to multiply 3 by itself 3 times, we would write 3 to the 3rd power, and 3 multiplied by itself 4 times would be 3 to the 4th power. So we see that when we add 5 copies of 3, we write 5 times 3, because 3 is being multiplied or added several times. But when we multiply 5 copies of 3, again, sticking to the same order, we talked about adding 5 copies of 3, now we're talking about multiplying 5 copies of 3. Notice how we write this, it's 3 to the 5th power. So multiplying by 5 in the context of addition, because remember, multiplication is just repeated addition, corresponds exactly to the superscript of 5 in the context of multiplication, because now we have repeated multiplication. So notice how the 5 times 3 here corresponds to the 3 to the 5th power here. That's important, so make sure you write this down and reread it and see if you can write it in your own words, because this is an important connection. Be aware of the correspondence between addition and multiplication, because what you know about repeated addition will help you learn exponents as repeated multiplication as we go forward. So whenever you get stuck, see if you can make a correlation between repeated addition being multiplication and repeated multiplication as being exponents. Alright, so now let's get to your lesson worksheet. What I'd like you to do is take out your highlighter and then highlight the important key points in the box about exponential notation. You will want to reread this and study it and be able to say it from memory because these definitions are going to be important. What you also want to do to solidify your learning is to copy this down in your math journal. Since it will fall in line with your notes and our discussion, it's important to copy what you have on your lesson worksheet in your math journal. Just that act of writing it down will help put this into long-term memory. So do that and then continue the video. Alright, so let's take a look at examples 1 through 5. You're going to do this in your journal. You're going to write in an exponential form or in expanded form depending on what the example is. So copy down the problem and write it in this case, example 1. You have expanded form. You're going to write it as an exponent. Same thing for number 2. For number 3, it's already in exponential form, so you're going to write it as expanded form. And then number 4, and then number 5. If you want to try this yourself, go ahead and stop the video and try it, and then continue the video and check your answers. If you want to, if you're not exactly sure, then go ahead and let's do these one at a time. Alright, so for example 1, you should have 5 to the 6th power. Again, be careful when you write this. The 5 should be bigger, the 6 should be smaller, and it should be kind of up above the 5. You don't want to make this look like 56. It should be 5 and then 6 up above, a little bit above the 5. Alright, for number 2, 9/7 repeated, multiplied by itself 4 times would be 9/7 to the 4th power. For example 3, this would be -4/11 repeated each time multiplied by itself, and you should have 3 copies of that. For number 4, if we have -2 to the 6th power, then you should have -2 times itself 6 times. And for number 5, 3 8/10 raised to the power of 4 would be 4 copies, 3.8 times itself 4 times. Right. Notice the use of parentheses in examples 2, 3, and 4. Do you know why? Why, I'm going to go back to this, but why do we have parentheses here, and the parentheses right here? Okay. Well, in cases where the base is either fractional or negative, it prevents ambiguity about which portion of the expression is going to be multiplied repeatedly. And again, let me go back to this. This is not going to be 9 to the 4th power over 7. This is 9/7 to the 4th power. So that's why, especially in this case, it's super important to have the parentheses to show that it's not just the 9 to the 4th power, but it's 9/7 to the 4th power. And here it's just making sure that you're carrying the negative sign throughout the whole expansion, because again, we don't want to have 2 signs next to each other. The parentheses separates those out. Okay. Suppose n is a fixed positive integer, then 3 to the nth power by definition is 3 to the nth power equals 3 times, and then we use a ellipsis, kind of a raised ellipsis, to show that this continues 3 times 3 times 3 times 3, and then we usually put the ending times 3. And then we use a bracket to show that this whole thing is being multiplied n times. So when you want to show, obviously if this was 3 to the 100th power, we're not going to expand this by copying 3 100 times. So this is kind of the accepted way. You kind of start with the beginning and the end, and then you put the 3 ellipsis. and then underneath that you show how many times are we multiplying this. So this example is very important to write down because you're going to be practicing writing this. So make sure that you adhere to this abbreviation. So please write this down. Make sure you have this in your journal. Actually, any of these should be in your, or all of these should be in your journal as part of your notes. All right, and let's apply this again. If n is any fixed positive integer, then by definition, if I have 7 to the nth power, you're going to write it like this: 7 times, and then ellipsis, times 7, and in brackets and underneath you're going to write n times. If it's 4/5 to the nth power, same thing. And even if it's a negative, negative 2/3 to the nth power, you start with the negative, you end with the negative, and you put underneath how many times you are multiplying it. So in general, for any number, x to the first power is always x. That's been defined earlier. And for any positive integer, that means n is greater than 1, then here is the definition. X to the nth power, so any number x to the nth power where n it has to be greater than 1, then you're going to show that you're multiplying this x times, and notice how they're using the dot for the multiplication because it would kind of look silly if we had x times x. It would be very confusing and very ambiguous as to what is that multiplication sign. So in this case they use a dot, and then they use the ellipsis again to show that we're multiplying by x and then n times. So again, highlight this definition. This is going to be really important as you do your explanations. All right. So if you're wondering about the values of n that are not positive integers, so our exponents that are not positive, positive and negative fractional exponents will be introduced in Algebra 2. So you're going to wait until high school to see that. And negative integer exponents, remember integers are just the opposites of whole numbers, we're going to be talking about that in Lesson 4. So that's why right now everything's being identified as a positive integer, just so we can establish what the definitions are, and then we'll start talking about negative exponents. So the number x to the nth power is called x raised to the nth power. So when you read this, this is x raised to the nth power. N is called the exponent of x, and x to the x to the nth power, and x is called the base of x to the nth power. So some vocabulary here that you need to make sure you have written down and practice. You'll be using these in your presentations, but this is the vocabulary you want to practice using. So we have common exponents like squared. X to the second power is called the square of x, so you don't have to say x to the second power or raised to the second power. And another common one is x to the third power is called a cube. So you can say it could be 5 cubed or 5 squared, 10 cubed, so on and so forth. So you can use, in place of raising to the second and third power, the words square and cube. And you've seen this kind of notation before when you expanded whole numbers using powers of 10, and again this is called exponential notation. So when you use exponents, it's called exponential notation. All right, let's take a look at exercises 1 through 10. You are going to complete these exercises on your lesson worksheet. And when you are done with that, go ahead and continue the video so you can check your answers. All right, so here are the answers. They are in blue. And just go ahead and check to make sure that, and make any corrections. Again, as you're correcting these, if there's a question as to why you don't understand one of these exercises, please write your question down either on a sticky note or in your math journal and highlight it, and you will bring those questions to class so that you can get those answered. That way we can highlight or instead of wasting a bunch of time, we can take care of problems specifically. So make sure you are writing those questions down. All right, when you're done checking your work, go ahead and continue the video. Okay, let's take a look for exercises 11 through 14. We want to make sure that you are explaining these correctly, so I'm going to show you what a sample answer will look like before you do the rest of them. So let's take a look at the first one. Will these products be positive or negative, and how do you know? So that's going to require a written answer. And the first one is here. -1 times -1 times -1, which is 12 times, is -1 to the 12th power, and it's asking how do you know whether this will be positive or negative. You're going to answer these in your lesson worksheet or in your math journal. If you don't feel like you have enough room on the lesson worksheet, you can answer these in your math journal. And make sure your explanations are thorough. Again, we want written explanations that are in complete sentences so that you can practice doing these for your not PARCC assessment, but for your standardized tests and for your assessments for math class. All right, so here's our example again. And here is an example answer. So it's asking, will these products be positive or negative? So you want to use your answer, or the question as part of your answer. This product will be positive if, and here's our explanation. I could have said this product will be positive because, or you can just start a new sentence. So if -1 times -1 is equal to +1, which means if I have 12 of these, there are 6 groups of 2. If this times this is a +1 and I have 6 of these groups, then 1 multiplied by itself 6 times is a +1. Therefore, so here's our conclusion, therefore -1 to the 12th power, which was the answer here, is equal to a +1. All right, go ahead and stop the video and answer questions 12 through 14. They're going to be similar. And then check your answers and make any corrections and write down any questions as you finish these. All right, so here are the answers for 11, 12, and then you'll have to go on to 13 and 14. Again, read the answers. Your answers should look like this, and you need to state, actually they won't look like this. These are explanations as to what you should include in them, but make sure that you are writing incomplete sentences, and we will go over these in class. When you are done checking your work here, go ahead and continue the video. All right, and here is for 13 and 14. When you're done checking your answers here, go ahead and continue the video. All right, so here we are at the end. At the end of each lesson exercises, there's always a closing or a summary, and you'll want to make sure you write this in your journal. So why should we bother with exponential notation? Why not just write out the multiplication, being that it would be repeated? Well, like all good notation, exponential notation saves in writing, so that we're not wasting a bunch of time writing the same thing over and over again. And exponential notation is used for recording scientific measurements, so exponents are used a lot in science. They're used for writing very large and very small quantities, and it's indispensable for the clear indication of a number's magnitude. And you'll see what that means when we get to lessons 10 through 13, because we will be using exponential notation. And here's an example of a labor-saving aspect of exponential notation. And here's something that comes from science. Suppose a colony of bacteria doubles in size every 8 hours For a few days under tight laboratory conditions, if the initial size is some number b, what is the size of the colony after 2 days? And what we would do, because it is growing or doubling in size every 8 hours, well, in 2 days there are 6 8-hour periods, so the size will be 2 to the 6th power, because remember it's doubling every time, or doubling in size in every 8-hour period. So that means that it's repeated multiplication, so 2 to the 6th power times whatever our number b is. All right, so here's the beginning of our study into exponential notation, and we'll see you in class.